In this video, we will be covering writing and graphing equations of a circle, which begins in section 10.7, page 699 of your textbook. This section begins with using the Pythagorean theorem to write a general equation for a circle that is centered at the origin here. So it is important that we note it is centered at the origin. So we just use the Pythagorean theorem. X squared plus y squared equals r squared. So it should look like a squared plus b squared equals c squared, where the hypotenuse is the radius, and the sides of the triangle are the x and y. So for any point that is on the circle, whether it is right there, or if I draw another right triangle right there, it would fulfill this equation. Now, if we were to center our circle at a different point, that changes our standard equation. So let's say we move it to where the center is hk and the radius is still r. So that changes the equation to x minus h squared plus y minus k squared equals r squared, all right, where h comma k is the center. Alright, so we're going to be given different pieces of information and have to plug it in to find the general standard equation for the circles that we are trying to identify. So let's just look at a couple of examples. In our first example, we're going to be using the center -2, 5 and the radius of 7. So into my equation, I want to do x minus -2 squared plus y minus 5 squared equals 7 squared. So when we actually want the standard equation, we do want to go ahead and square these and then simplify our symbols here. So our final equation here is x plus 2 squared plus y minus 5 squared equals 49, and this is my equation for this circle. And if a point were to lie on this circle, that means when I plug in that point, x and y, it would equal 49 on the left for a true statement. Alright, so let's look at another example given different pieces of information. Alright, so in our second example, we have a point 3, 4 on the circle and a center at 1, 4. So into our equation here, x minus h squared plus y minus k squared equals r squared. This time we don't have the radius, so we need to plug in what we know in order to solve for the radius. So I do have an x value, and that x value is 3, and my center occurs at 1. And then I have a y value, and that would be 4 minus my k, which is 4. Equals r squared. So you can label this hk so that you know this one's the h and k and this is the x and y. Okay, so 3 minus 1 is 2 squared, plus this will end up being 0 squared equals r squared. Alright, if 2 squared equals r squared, that means 2 equals r. Alright, so my radius is 2, so then when I plug my center and my radius back in for my final equation, I will get x minus 1 squared plus y minus 4 squared equals 2 squared, which I'm just going to go ahead and replace that with a 4 and multiply it out. Now, whether you are given this information or you are given the graph of a circle, we should be able to figure out a center and the point on the edge of a circle and plug in that information to find the equation. We might also be given the reverse information, so you might be given the equation and have to figure out the center. Given the equation of a circle, you might also have to graph it. So, I know from this equation my center occurs at 4, -3, and that my radius is not 16. My radius, keep in mind this is r squared, alright, my radius is going to be 4. So I can actually graph this. So I want to draw my x and y here. So I want to go to 4, negative 3, and here's my center, and my radius is 4. So I'm going to go up 4, I will go down 4, to the right 4, and to the left 4. Now this is an approximate sketching. We did do a activity in class trying to draw a perfect circle. Alright, so this is how you approximate. You just want to go up, down, left, and right. It's going to be difficult counting 4 when you are traveling across the hypotenuse here. Alright, and that's just about all that we need for this section. So good luck and happy graphing.